In this recording, I will show you some of the fundamental theorem of calculus for integrating very basic integrals such as this one that we will encounter during this course of electrodynamics. Well, here it asks to find the derivative of this integral, and notice that the derivative here is with respect to x, and we have a term that has a y here and a term that has an x. And so what we could do is we could split this integral into two, and this goes 0 to 1 ln y dy plus 0 to 1 ln x dy. And this is of course differentiated with respect to x. Okay, now ln x here is independent of y, so this just becomes ln x times the integral of dy, which is y from 0 to 1, which will just be 1. So this second term here will simply be ln x. Now the first term here, we do have to use integration by parts. So by parts to integrate ln y, and why don't we do it on the side, and then we'll come back and we plug it here. So as of now it's 0 to 1 ln y dy, and when I'm done with all the stuff, I will take the derivative of this with respect to x, and let's call this equation 1. So I'll go ahead and work out 0 to 1 ln y dy, and for that, as we said, we need integration by parts. So I'm gonna let my u to be ln y, dv to be dy, and by this logic du equal 1 over y dy, and v will equal y. And integration by parts, as you know, the integral of u dv is just uv minus integral of v du. So if I apply this on this guy here, I would get uv, so that's y ln y minus integral from 0 to 1 v du, v is y and du is 1 over y dy. Conveniently enough, these two guys go away, and we get y ln y minus. Now keep in mind that the ln y blows up at 0, so that is undefined, right? So what I could have done here is I could remove this and put a t, and I could take the limit as t goes to 0 plus, because the domain of the ln is 0 to infinity, and as such I could change this likewise to t, oops, sorry, it's the lower bound, t to 1, and when I'm done I will take the limit of this whole thing, because this also goes from t to 1, and I will take the limit of this whole thing as t goes to 0 plus. Okay, let's leave some space here. So this is equal to 1 ln 1, so evaluating now upper bound minus lower bound, minus t ln t, minus integral of y is just y from t to 1, and when we're done we will take the limit as t goes to 0 plus, and so this becomes 0, ln 1 is 0, so we get minus t ln t minus y, minus 1 if I evaluate at 1, minus minus, this becomes plus t, and I will take the limit as t goes to 0 plus. Now if I plug in here 0 plus, we will get let me factor out a t, and then we would have have 1 minus ln t, right? Minus 1, and we will take the limit as t goes to 0 plus, right? And to evaluate this, we would have 0 plus times 1 minus ln 0 plus minus 1, right? Now ln 0 plus, that's minus infinity, so we will get here 0 times infinity, because we have minus minus 1. This guy gives us a 0, and so we get the final answer to be minus 1. Plug in 1, so this is the first part of the integral. If I plug it into 1, I would get now d over dx okay, so this whole thing turns out to be 1 plus ln x. Okay, and then I just differentiate with respect to x. So obviously the first part is 0 and the second part is 1 over x. This concludes this problem.